This is a tutorial for the Agrotech CTF calculation module. This is the first sheet, it's the visualization sheet. First we define the precision. It defines how many millimeters each cell is in the width. So here we have a precision of 200, and a high value here will give you a low calculation precision, and a low value here will give you a higher calculation precision. And you can see if this value is 50 or below, there will be no animation. It's defined in millimeters. The field width is 24 meters, and this width here, and we have a boolean value to define if we want the implement marker to show or not, 1 or nothing, or 1 or 0, and we have a column width and a row height, which will define the visual screen here, depending on the resolution, so you can tweak this and you can play around with it a little if you like. We go to the buttons. If you press the overview button, you will get this screen where you can see all the machines and the axles and how they are aligned on a field, and you can see the percentage of the tracked and the uncropped area. The uncropped area is defined by black tracks. If you press the calculate button, we will get all the machine axles one at a time, and at the end of each animation or overview, the whole screen here will be copied to the clipboard, and you can easily copy it to your document. As you can see, the uncropped area will be visualized again one last time over all the other tracks here. You can also see this value here, 1. It's because of this cell. It's been overdriven one time, and these here are overdriven. This cell here has been overdriven 9 times, and this can be shown in a color map if you press the color map button. This will also be copied to the clipboard, and you can see this screen be generated. These values here are user defined in the input sheet. I will get back to that a little bit later. Before that, I will try to press the uncrop button, and it will visualize the uncropped tracks defined in the input area also. So this button will go to the input area. Before we go there, I'll show you the results sheet where you can see the data, and you can see that these have a bigger precision than shown here, and this is only a helping sheet, so much more to tell here. In the input sheet, you can define the machine count. We have 3 machines here. We can specify 10 machines, and we will have 10 machines. It will copy the first machine from where we started, from 3, and we have 4, 5 to 10 as the first machine. We can jump back to 3 machines and the rest will be deleted. Be careful with this function because it will delete your machines without asking you first. And here we have the user-defined colors for the color map, and also the values here are user-defined, so you can change them and it will be implemented in the visualization. We can change the color of the machine by changing the color cell here for the color we like, and we have to update colors here, and the rest of the axle will also change the color. So, but we can also change a color of one axle here and it will also work. We have the go to visualization shortcut and we can go back again. So we have the name or the ID of the machine, the name of the machine, and the implement width of the machine in millimeters, and we have the overlap percentage. We also have the start position. Here we can have a negative start position or a positive start position to define or to align our machines here. We have talked about the colors. We have 5 axles here, and we can just add an axle by typing actually we can just have all the 6 IDs here, and it will check if there is a track width. So if there is a track width here, it will calculate an axle here. And we have the tire width, and this is the ungrown area Boolean value. So if we say that this axle will leave an ungrown area, so we type 1 and it will become black. We delete it and it will turn the default color again. So here we have an overlap and here we have a negative start position. So we have a visualization template where we can define the default colors, default size of the screen, and it will be the standard input every time we run a simulation or an animation or any calculation. We have a short user manual, and that's about it. Give it a shot.